Hi everyone, my name is Liz McCreish and I'm here today to talk to you about how you can empower your business analysts to become citizen data scientists. Traditionally, the users and tools for reporting, analysis and analytics were pretty siloed, and in order to apply analytics you needed specialist tools that required coding skills. But over time, it's become more of a continuum as analytics tools have been adding more intuitive interfaces and visualization capabilities. BI tools have been adding more analytics capabilities out of the box, as well as exposing the capabilities of open source tools such as R and Python to analyze data on the fly. And by moving people up the continuum further to the right, they're able to perform more tasks for themselves, and as they become more able to perform analytics, they are evolving into citizen data scientists. So what do we mean by a citizen data scientist? The term was first used by Gartner in 2015, and there are a number of definitions, but we prefer a person who creates models for business use, utilizing advanced analytic tools and technologies, and statistical or machine learning methods, but whose main role is within the business side of the organization. Traditionally, hiring data scientists is expensive. It could also take time for them to understand the business drivers. The relative cost of training citizen data scientists can be lower compared to hiring an external team, and business functions can prioritize the ideas where they see the highest potential value and quickly identify where their hunches are accurate. So I'm guessing the question on your mind at this point is, can it work? I mean, all of this may sound great in theory, but if it was easy to take business users and turn them into data scientists, surely everyone would be doing it already. Now, I'm not going to promise it's easy, but in the next few slides, I want to lay out what I think is needed, and then we'll set out a blueprint for how we can help you to get there. We believe that these three key areas cover the skills required for data scientists, but what this diagram doesn't highlight is the balance between those skills. Typically, when you go out and hire data scientists, they'll have been trained mainly in the statistical and technical aspects with limited business knowledge. What we're looking at with the citizen data scientists is taking users who already have strong business expertise and bringing the technical and statistical fluency up to a level where they can usefully build and evaluate models, and these can help understand the business drivers and opportunities to add real value. So what this does mean is that often you want to back up your citizen data scientists with trained statisticians checking the models and IT experts to ensure that any models you're planning to use in production are built in a robust and scalable manner. But what it does allow is business users to take their knowledge and drive the direction of the data science strategy, taking their ideas and building proof of concept like models, with the data science and IT teams taking the best outputs into production. So our question becomes, what's the minimum comfortable level of each of these skills to make citizen data scientists effective? So let's start looking at these areas. If we start first of all by looking at the business expertise, this is the obvious advantage of the citizen data science approach. The business expertise is the bit you get for free with this group. We're taking a group of people who know the business processes intimately. They know the most important drivers, they're familiar with the metrics used to track the business, and they can easily sense check any model outputs against real-world experience. With statistical understanding, you may already have people trained with some statistical background, whether that's from their maths, stats, computer science, or engineering degree, but also a lot of social science degrees, for example, involve a large element of statistical training. By then furthering on this and training on best practices, the types of models available, considerations and techniques, you can achieve a solid base from which to start testing your own hypotheses. And then we come to technical know-how. Traditionally, this was one of the big blockers for business users getting hands-on with statistical modeling. The traditional tools such as SAS, SPSS, R and Python expect deep knowledge of statistical models and an ability to write code. While they offer a lot of flexibility, things like R and Python have a fairly steep learning curve that not only puts users off, but also makes the training and investment more costly and increases the time from starting the training to getting hands-on with data for the business processes. What we've seen over the last few years is the emergence of user-friendly drag and drop tools that allow users to build a process flow, such as loading the data, doing some minor data cleansing, building a model using the default parameters, maybe changing some of those if you so want to, but it means you can start to build models very quickly. This represents a serious opportunity to get advanced analytics in the hands of business users who might previously have been put off by coding and an overwhelming choice of parameters at every step. So a few of these user-friendly tools are displayed here. The tools allow varying levels of model customization, so you do need to understand a bit about analytics in order to understand which models are applicable and how to interpret the results. Some of these tools are more of a black box where you upload your data and the model is chosen automatically and the magic answer of 42 is spit out. While this may seem like the simplest route, just add a word of caution as you still do need to understand what the selected model is and what parameters have been used in order to have confidence in the results and ensure that it's meeting the business needs. Next, I'm going to talk through a blueprint that we've designed to provide a roadmap to grow your own citizen data scientists. So first of all, who should we be looking at? One place to look would be strong analysts who use visualization tools such as Tableau or Power BI, but would like to take it a step further. These are the people who aren't content with standard reports and will be keen to add their own take on it. Also, who is that guru that can manipulate data using Excel and pivot tables and lookups and adding their own KPIs and calculations? Who are the people who do their own data mashups to augment the official data sources available with other external and internal data? If you can give these people the platform and capabilities to go further, then you can also advance their thinking and the insights available. So one of the skill areas we mentioned was statistical literacy. It is important that the citizen data scientists are aware of statistical techniques that are available to them, but also understand the context of when they were applicable, which methods only apply to numeric data, and understand the importance of training a model and evaluating the results. The blueprint that we have designed is a way to help kickstart your building a practice of citizen data scientists. The first step is to do some groundwork and agree a tailored training plan for your needs. For example, if you're part of the marketing department, a lot of the potential methods around text analytics may be key for you, but maybe someone in finance, they may not be of any benefit. We also need to talk about infrastructure. A number of our clients prefer us to set up some cloud servers to support analytics work while they build up the business case for longer term investment. This is something that we can do, or if you have infrastructure in place, we can also work with that. Understanding the size and the shape of the data is also key so that the servers can be provisioned accordingly. Also important are security considerations. Are there any restrictions on where your data can be hosted or processed? Does any data need to be obfuscated? So once all that's been agreed, the initial training is delivered on generic data so that users aren't sidetracked by data questions and queries, but are focused on the tools and techniques. An example of some of the topics covered in the foundational learning training is displayed on the screen. And as you can see, it covers a combination of technology training, statistical methods, and some guidelines around processes and best practices. In the second week, we start using your own data, but applying the skills learned in week 1 to real-life business questions. What impacts are my promotions having? Which customers are likely to leave? And which customers should I promote my new product to? We would work with your team to investigate your data and provide input on suitable methods and data transformations to apply. For the remaining 8 weeks, you should be encouraged to further investigate, perhaps identify additional data sets that could add value, and along with support from us, start to share knowledge and share findings within the team. For example, an analysis that a brand manager has undertaken for products may also be useful if applied by a finance manager to their cost centres. At the end of that period, a review would be undertaken to decide whether to perhaps extend the setup for a longer time frame, if you decide to productionise the system and make it available to wider teams, or to shut it down as there was no business buy-in or the benefit was not seen. So how can we help? Thorogood actually started out of an operational research department of an advertising agency, so we've been involved with analytics since day one. As head of our analytics practice, part of my role is to ensure that we keep abreast of the latest technologies that are available, train our consultants to meet the needs of our customers in servicing analytics engagements, and also lend a hand on projects which have an analytics aspect. Across all of our locations, we have pools of consultants with analytics experience. In addition, we frequently run webinars and in-person workshops for our customers, sometimes focusing on certain technology capabilities or more general applications of analytics, and many of these are available on demand on our website. This is an example of a program we run with a global insurer. It's an 8-month program that's being run across multiple business units and multiple technologies, with an expectation that it will become self-sustaining by training the trainers and using community knowledge. In this example, it's a pretty comprehensive and expansive program, but we've also covered similar topics in varying scales. And then we mentioned infrastructure earlier. So depending on the size and complexity of your data, one or more of the layers shown here may be required. And while you're proving the business value, this is where the ability to spin up servers in the cloud and turning on and off compute power can make a very cost-effective solution. So just to summarize, we focused in on those 3 key areas. So identify where there are knowledge gaps and train them in, as it is the combination of all 3 skill areas that provide the biggest benefit. But make sure there is sufficient support and guidance available. You don't want people making decisions based on faulty rationales and incorrect models. Review that the program is working. If you aren't seeing the business benefits, then your setup may need to be revised. So if users are ready to take the step, but the platform isn't there to support them, you're going to be missing out. If you have the platform in place, but people aren't enabled to use it, you're also going to be missing out. And there's a lot of opportunity here. So thank you for your time today. If you would like to know more, please feel free to reach out and get in touch. And I look forward to hearing from you.